So
Yeah.
what's the solution? Is it essentially increasing the glass width on the front side or and making a stronger glass, like a bulletproof glass or whatever the equivalent of that is? And just to kind of like put this in perspective for most viewers' benefit, I mean, solar panels, they do, I've done some solar utility scale solar development in my past, and we used to plan, 0.55% or half a percent degradation per year over the 20, 25 years of lifetime that you project for these
Mhm.
systems, which generally, I mean, talking to some really old, decades old solar people, they all say panels will last 40 years, even 50 years at maybe 70 or 80% efficiency from 40 years ago. And that's
Mhm.
generally the case. You lose maybe half a percent or even less these days on a year basis in terms of the capacity of that system.
Mhm.
And used to be 80% warranties, now 90% warranties 20 years into the asset life or 25 years. So everybody expects to lose some efficiency of that production capacity, 10% or whatnot. And this ebook refers to 5 out of 10,000 faulty panels too, which is really, if you add up over 25 years, only 1.25%, which is very little compared to the 10% or so degradation that could happen. So these are
Yep.
all like normal little inefficiencies that you see through the life of a solar asset. But obviously, when a hail comes, it can rip apart the entire system or just damage all the panels, and
Right.
you're losing 90% or 100% of the asset. So, what is the way to mitigate that? I guess is the
Yep.
question.
Yeah.
And
So, like you're saying, we've gotten really good at manufacturing modules at this point, Trina and others, to the
yeah,
point that they are reliable and they will perform as long as they're not crashed into by a giant ice ball and broken apart. And so,
yeah,
yeah, the way we mitigate it, we looked at a couple different options, and there are a couple different options across the industry as well.
mhm,
But I mean, the end of the day, you are increasing the thickness of the glass essentially to make it less susceptible to breakage and damage from hail. And so, our core product is the NE19. We'll show a slide on that a little later, but
yeah. Why don't
our
I pull that up?
standard dual glass modules have 2 millimeter front glass and then 2 millimeter glass in the back. And the NE19, the hail resistant module, is 3.2 millimeter front glass with just a back sheet in the back. So it's not dual glass, glass on the front, back sheet on the back.
This
Um,
one, the one in the middle we're talking about.
Correct. It's
Or,
the one
yeah,
kind of on the right of those middle two,
yeah, yeah.
NE19RC there. So it's very
Right.
similar to our NEG19RC. The cell, most of the bomb, the encapsulant, the frame is all very similar,
Mhm.
the same essentially. It's really just the thickness of the glass that changes that gives it its hail reliability. So it's
Got it.
not a major change, but it's important in terms of dealing with you
So,
know
how much thicker is that glass versus the regular product?
Yep. So the NEG19 on the left of those two there has two
Yeah,
millimeter front glass and 2 millimeter back glass. And then
yeah.
the NE19RC on the right there, the hail resistant, that has 3.2 millimeter front glass and no glass on the back. So the
Got
reason
it.
we did that, other companies are also doing, they're looking at 2.5 millimeter front glass and 2.5 millimeter back glass. So
Mhm.
thickening both the front and the back. We preferred the 3.2 and clear backsheet because if you look at the overall weight of the module, we wanted to beef this thing up without making it difficult to
Too much.
install, difficult to ship,
Right.
increasing
Got
costs
it.
in that way. And so uh, the 3.2 millimeter and then the backsheet is actually less overall glass than 2 millimeter, 2 millimeter. And so it keeps the cost or the weight down, which makes it easier to install, easier to ship, et cetera. And so that was kind of our solution as opposed to the 2.5, 2.5, which increases the front glass less thick, like makes it less thicker, so less resistant to hail, and then
Mhm.
also kind of increases the overall weight of the module quite a bit. So
Got it.
yeah,
Well, great. Thanks for all that info. One other topic I want to touch on this topic of hail. and resistance is how do you guys test this product? Like I'm going through the ebook, it seems like a quite intensive process to of testing that you guys go through as well to make sure these products are truly hail resistant. So can you tell us a little bit about that testing process and then maybe the
Yeah,
results?
yeah, for sure. So we obviously do a lot of testing internally, but when we're selling to customers and the industry at large, you need third-party backing, obviously, on your results so that they're more trustworthy, et cetera. And so there's kind of two main agencies that we test with. One is PVEL and one is RETC. And so they have kind of set different testing protocols. PVELs, it's very similar to the IEC standard I referenced earlier, which
Mm.
the IEC standard is up to 25 millimeter hail thickness. The PVEL testing goes up to 55, I believe, maybe even 65 millimeters at this point. But the
Yeah.
way they do testing is essentially you have a module here and you're impacting it with hail perpendicularly. So
So do you
at a
like
right
throw
angle.
a do you like throw a like a bullet as if like you're shooting a not a bullet but a ice ball into the panel? Is that
Yeah,
essentially?
basically exactly that. And the p-val method is again direct on. So I get 90-degree incident angle
Yeah,
directly against the module, and I believe
yeah,
it's 7 different locations around the module. So you'll do that with the different thicknesses of hailstones, and you'll essentially see what thickness the module will stand up against,
yeah.
and kind of go up in thickness. So you'll start with 25 millimeters, 35 millimeters, 40, essentially up to its failure point. So
And what's the speed you throw the ball at? Is it the same as speed as it would get with gravity, I guess?
I don't know it offhand. It'll be in the ebook,
Mm.
but it's essentially you're looking at the overall energy impacting the module. So it's kind of the thickness and the speed together, and you're seeing that
Yeah,
the module can withstand that. But it's relatively fast. And if you get up to like 55, 65 millimeter hail balls, that's like the size of a billiard ball. That
yeah,
could do a lot of damage. But
right.
if you look at the testing on the ebook, you can pull that up, and the kind of dual glass, or sorry, the 3.2 millimeter glass
Yeah,
modules are quite
there
a
it
bit
is. Yeah,
more kind of able to withstand hail than the standard 2.2 millimeter modules.
right. So these are like essentially 65 millimeter hail resistant. Got it.
Correct, correct.
Mm.
But you see the stow angle on there, and so that kind of
Right.
brings in the another kind of
Yeah.
uh, part of the
Yeah, that's the
testing.
other I guess mitigation method that asset owners use to protect their asset is they can if they have vertical single even single axis trackers, I guess would be enough for that, is
Mhm.
they turn the panels vertical when the hail is coming down, and then that
Correct.
obviously can.
So yeah, trackers have different stow angles, and
Yeah,
those have been around forever. They're used for wind stow.
yeah,
If you want to get snow off the modules, you take them as
yeah,
close to vertical as possible and dump the snow off. And
right,
now stow angle is pretty important for hail as well.
yeah.
And so trackers historically,
But
I believe,
sometimes hail comes down like without much warning, and it can happen like in just a few minutes. Are
absolutely.
they smart enough to notice that and turn vertical on their own? Is there that
Some of them are
intelligence?
getting towards that. Right now, the industry standard is not necessarily automated on the hail side. And so, what
Hmm.
you would have to do is called a manual stow. So, you would
Yeah,
be looking at kind of weather data. And if you think a hail event is coming, you would manually stow at the kind of max angle that your tracker will allow. And
and you can do
different
that obviously remotely, right?
remotely, correct? Yeah.
Yeah, yeah, got it.
So different trackers have different maximum snow angles. For a while, the industry standard was 60, but
Hmm.
with the rise of hail, similar to how we're developing these hail-resistant modules, tracker manufacturers are kind of increasing the maximum angle of their stow in order to kind of be more
Yeah,
reliable
like more
against
like
it.
75, something
I,
like
I
that.
believe 75, or at RE Plus, I think one of the companies mentioned something like 77. So it was going
Oh
from
wow.
75 to
Um,
77. And it's very important. So
yeah,
that
yeah, those few degrees can make a big difference. And
for sure.
clearly the other badly needed intelligence or AI or software capabilities to notice that hail is happening, so you
Yep.
activate a stow really fast, because that can save millions or hundreds of millions of dollars for the industry and
Correct.
companies.
I'll talk a little bit about that in a second, but speaking of
Yeah.
stow angle, that kind of bridges nicely to the other testing agency we work with, which is called RETC. And
Mm-hmm.
their testing protocol is different from PVEL in the way that they can control the impact angle of the hail against the glass. And so we're able to test at, say, 60-degree impact angle,
Got
55,
it.
40,
Got it.
etc. And so that's
Got it.
why when you look at that kind of section of
Table.
testing results on
Yeah.
the ebook, it has 65 at, I believe,
Right.
60-degree tilt. So yeah, we kind of work with both agencies. They have two different protocols, but they're both very robust and very useful information.